Welcome everyone to our JAMB series. We are treating set, still on the definition of terms. Today we'll be starting with complement of set. The complement of any set, say K, is a set that has every element in the universal set except those of K, denoted by K prime, which can be K raised to power 1 or K raised to power C. Example, if the universal set is equals to 1, 2, 3, 4, 5, and the subset K is equals to 2 and 5. Find K prime. That's the complement of K. Solution. The complement of K is equals to 1, 3, 4. That is simply the universal set minus the subset K, which is equals to K complement. Another term, finite set. These are countable sets. Example, 1. The set T equals to all the governors in Nigeria. Of course, that we can know with ease. Another example, the set Z equals to all the students sitting for JAMB exam in 2024. That can be easily gotten from the JAMB office because the records are available. Another definition of term, infinite set. These are uncountable sets. Example, the set D equals to X such that X is an element of natural or counting number. Example 2, the set F such that X is an element of integer. The next terminology is disjoint set. Two or more sets, say A and B, are said to be disjoint when they have no element in common. That is A intersection B equals to empty set. The next terminology, non-disjoint set. Two sets, say C and D, are non-disjoint set when they have at least one element in common. That is C intersection D is not equals to empty set. That is C intersection D is not equals to empty set. Example, if X, the set S is equals to A, B, C, D, and the set Y is equals to A, comma B, and the set Z is equals to C, comma D. Find a non-disjoint set. Solution, A, S intersection Y is equals to A, comma B. They are non-disjoint set. B, Y intersection Z is equals to empty set, which is to say they are disjoint set. Next, we take some problems that treat the basic theorems that we have learned, number set problems. First example, if X is equals to all prime factors of 44 and Y is equals to all prime factors of 60, the elements of X union Y and X intersection Y respectively are, the options are given. Solution. Before one can attempt the question above, you must recall your definition of factors, prime, and then know what is prime factors. Factors of 44 is equals to 1, 2, 4, 11, 22, 44. Then X, which is prime factors of 44, is equals to 2, 11. And Y, the prime factors of 60, is 2, 3, 5. Hence, their union, X union Y, will be equals to 2, 3, 5, and 11. Whereas their intersection, which is X intersection Y, is equals to 2. Another example. If the universal set is equals to S, P, L, E, N, D, O, U, R, and the subset X is equals to S, P, E, N, D, and the subset Y is equals to S, E, N, O, U, and the subset Z is equals to P, N, O, U, R. The question is, find X intersection into bracket open Y prime union Z bracket close. The options are given. Solution. Firstly, we start with the bracket part, that is Y prime union Z. Note that Y prime is equals to those elements in the universal set but not in Y, which is equals to P, L, D, R. Then Y prime union Z will be equals to P, L, N, D, O, U, R. Therefore, X intersection Y prime union Z will be equals to P, N, and D. Another example. If the universal set is equals to 1, 2, 3, 4, 5, 6, and the set P is equals to 3, 4, 5, and the set Q is equals to 2, 4, 6, and the set R is equals to 1, 2, 3, 4. List the elements of bracket open P union Q bracket close prime intersection R. The options are given. Firstly, we treat the bracket problems, that is P union Q prime. And we know that P union Q is equals to combining both elements in P and Q without repetition. That is 2, 3, 4, 5, 6. Thus, P union Q prime will be equals to the universal set minus P union Q. And that is equals to 1. Therefore, P union Q prime intersection R will be equals to 1. Reason being that 1 is a common element between P union Q prime and R. Another example. Let P be equals to 1, 2, U, V, W, X, and Q be equals to 2, 3, U, W, 5, 6, Y, and R be equals to 2, 3, 4, V, X, Y. Determine bracket open P minus Q bracket close intersection R. The options are given. Solution. P minus Q is equals to, listen the element of P, which is 1, 2, U, V, W, X, minus, listen the element of Q, which is 2, 3, U, W, 5, 6, Y. This operation is done, we'll be left with 1, comma, X. Next, P minus Q intersection R will be equals to 1, comma, X intersection the element of R, which is 2, 3, 4, V, X, Y. And that is equals to X, because X is the only element common to two of them. Another example. Given the universal set U and two subset P and Q, where U is equals to 1, 2, the universal set U is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And P is equals to X, such that X is less than 12. And Q is equals to S, such that X is an even number. Find P complement intersection Q. The options are given. Solution. First, we find P complement, but we know that P is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 is not included because of the strict inequality there. Thus, P complement will be equals to 12. Listing Q, we have the even numbers from the universal set, and that will be 2, 4, 6, 8, 10, 12. Therefore, P complement intersection Q will be equals to 12, which is the only common element between the two sets. Another example. Given that R is equals to 1, 3, 5, 7, 9, and S is equals to 3, 4, 5, and R prime is equals to 4, 6, 8, 10. Then the universal set U is, the options are given. Solution. The universal set U is the combination of all the sets R complement inclusive, given without any repetition of elements. Thus, the universal set, which will be the same as R union R prime union S, will be equals to 1, 3, 4, 5, 6, 7, 8, 9, 10. Another example. If P is equals to numbers less than 27 that have 3 as a factor, and Q is equals to numbers less than 25 that have 5 as a factor, what is the ratio of the number of P ratio to number of Q ratio to number of P intersection Q? The options are given. Listen the elements of each subset: 3, 6, 9, 12, 15, 18, 21, 24. The number of P is equals to 8. Note that 27 is not included because of the word less than 27. Q is equals to 5, 10, 15, 20. And the number of elements of Q is equals to 4. Note that 25 is not included. Reason, because of the word less than 25. Thus, our P intersection Q is equals to 15. And N of P intersection Q is equals to 1. It's just one element, the number of the element in P intersection Q. Thus, taking their ratio, N of P to N of Q to N of P intersection Q will be 8 ratio 4 to ratio 1. We've come to the end of the examples under this topic. Next, we have some exercises from page 111 of the hidden fact in JAMB mathematics. Please try your hands on the exercises. Answers are given at the answer section of the book, either in the hard copy or the soft copy, with our website address at the bottom of the screen. Thank you.